Hello everybody and welcome to today's workshop Player 2 CPU Ready. And in this workshop what we will be doing is creating a game using Unity game engine uh, and then adding AI opponents all done from scratch other than just the raw movement other than the raw movement that the objects possess. Everything will be done from scratch. So this might be your first ever workshop with regards to Unity uh, or game development in general. So I will tell you more about Unity for now. So Unity is basically a game engine in which you develop games and for which will be played by people. Okay, so very good examples of games that are made using Unity is Among Us, Fall Guys. A lot of indie games are made using Unity because it is fairly simple to learn. It is right up there in the alley with Unreal Engine, except it is Unity is far less complicated to learn to get started with. So if the first thing you would want to do when starting with Unity development is actually downloading the necessary software. The first is the engine itself. For that, you go to unity.com/download. From here, you can download for Windows, and if you go to other versions, then you have Linux and Mac as well. Okay. Once you have downloaded for Windows, it will download Unity Hub. So you install that. Unity Hub application looks somewhat like this after you have logged in. Okay, so when you open up Unity Hub, it will ask you to log in to the it will ask you to log in to the log into system. Okay, so in there you basically create an account, a Unity account, where here create a Unity ID. You can directly create your ID from the website or from here. uh, just give it a moment. Right now it is showing my own stuff because I already have a Unity account. Once you have done with the ID itself, then you need to get a license. You go to preferences and licenses, and you add a license which will let you to then you add a license which will allow you to use Unity. There, after adding a license, you go to then you go and install a version of the Unity editor. Right now I'm using 2020.3.27f1. It is the LTS just simply means long-term support here. And right now there is only one project here because the rest of the projects I basically cleaned up and saved it someplace else. And after installing Unity Hub and Unity Editor, you would want to install Visual Studio Community. For that, you can simply Google it, like, or you go, or it will just show you this one through this link: visualstudio.microsoft.com/vs/community. You download from here. It will download an installer for the Visual Studio installer. The Visual Studio installer looks somewhat like this. Right now I already have an installation of Visual Studio Community 2022 because it is Visual Studio Community is basically the free version that anyone can use. Available are also enterprise and professional, but most of us will be using Community since it is free. After we're done with all this, when you're installing VS Community, it will allow you to it will ask you what kind of development you want to do, and for that, what it will tell you that, and there you can get the game development with Unity. Since you have already installed Unity Hub, you wouldn't need to install it again. So around here where the developer news is showing right now, you will see a checkbox for Unity Hub, and you can disable it. So this is all the getting set up with the software. Now we actually get started with our project. So I'll create a new project. I'll name it the same as the event that is there. I'll call it player to CPU ready, and location is wherever you want the project folder to be, and we'll be using the 3D core template. We create the project, and we essentially just wait for Unity to create our project. And while it's creating, I will tell you about our main goal with regards to this workshop. So what we will be doing is we'll create a racing game, okay, a racing mini game, wherein you have two vehicles, one controlled by us, the player, and the other that is controlled by the computer, the CPU, or whatever you want to call it, an AI bot. Okay. Now you can use the built-in functionalities which are for the nav mesh agents. I'll get to those in a bit. And but sometimes, or usually most of the time, uh, you would want it to do very specific tasks, which is not exactly the kind that the built-in functions are made for. Not exactly an example per se, but say if you want extra information to be projected while all the nav mesh is working, you would want you're going to want it to have newer uh, you're going to have to make it like from scratch, or implement it from scratch, so that you can customize it to cater to your specific needs. And that's it for like the smaller explanation. Like, it's simple. Generalization is okay, but when you are actually doing work and need specialist tasks, you need specialization, of course. So the project is created, and the first thing we are going to do, since it's a car game and not a shooting game, we are going to add a 3D object, that's a cube. This will represent a car, and I am going to scale it for I suppose uh, I think this is good enough, I think. Yeah. Yeah. This will be our scale, and this is basically the cube. I'll create an empty object which will be a container for what the car is supposed to be like. Okay. And the cube is basically just a visual representation of how the car will look for now. Okay. We will give it a 3D object later on, and since it's just the visual, I'll just rename it to body. And a car has, it's not just the body, a car also has wheels. So I'm going to create an empty, which will basically be a container for the wheel, just like how we had a container for the car. Okay. And this is a front a front left, and also, like, I think it is off center the car. No, it wait, yes it is. We are going to put it to origin so that the body is exactly where the car is. Now the front left, alright, we were renaming it to wheel. I mean, it is a little bit long, but it is what it is. And I'll just copy and paste it 3 more times so that I have four wheel containers, and I'll rename it. So if there are like any kind of doubts, then you can use the chat as well. And once these containers are made, now we have the wheels, basically what the wheels will be contained in. Now we need to position them. One thing we should know is that when you're scaling anything, the Z axis is the one that goes forward and back. The X axis is the one that goes left and right, and Y axis goes up and down. This is very important information, and it is it's by convention to have all this together. Oh wait, yeah. And then the wheels, we are going to scale them. No wait, we don't need this scaling yet. The scaling will be done from the visual itself. So I will rename now I select this and add a 3D object cylinder. That is our wheel visual. I'll just call it wheel visual. And here we'll do our scaling 0.8, the axis 0.8, and y axis, because it's the vertical one here, and the vertical one is the thickness here, I'm going to put it 0.2 so that it is basically a wheel's proportions. And we're going to rotate it along the x-axis, not the x-axis, by the z-axis. Now I press this Y button, and it will go to the top down view. And I press this again, it will be shift your perspective. Okay, what is the viewing mode? This is the orthographic mode, wherein like the the closer up objects aren't exactly bigger. They will be the same size as the scale. Like if it is like 1 by 1, if the scale is 1 by 1 and it is closer to the closer to the viewing point, then it won't appear bigger. It is good when you are trying to model something. So front left visual, no, front left wheel, and think no yeah, 1.3 will do. And it's the left. How do we know where? How is it going the front? It's z-axis. Positive z is always going in the front. And x 0.9, no, negative 0.9. It is sticking out a little bit for now, but it will be it not exactly fixed. It will be improved on later, because right now it's clipping through the other stuff. And the positioning is done. We take the wheel visual, copy it through either Control C or whatever, and paste it. This is for the front right wheel. Paste it again. Rear left wheel. Paste it again. rear right wheel. All of the visuals are down, and we position these visuals to be exactly where the container is. Why was it not there previously when the wheel visual here is like 000? Then why was it not where the container is? It's because like the when you copy and paste this position, this is a local position basically. It is calculated with respect to the parent. But when you copy something, um, it will store the global position, which is calculated on the basis of like the world scale that's there. So the visuals are placed, then front right. So this front left is 1.3 minus 0.09, so this will be 1.3 and 0.9. Rear left, let's just push it back and see. This much should do. Yeah, 1.3 only, I think. Oh, minus 1.3 and okay, and minus 1.3, and it's the left one, so it's minus 0.9. And similarly, it's minus 1.3 and 0.9. The wheels are set, and now if we want the car to move like it is supposed to, so what we will have to do is add a rigid body component to it. What a rigid body does is basically allow us to move objects with through forces, and instead of directly manipulating position, rotation and scale. It is a very good method of it's a very good method for having the it's a good method. It's genuinely very good. It works. Oh, and also these wheels shouldn't be that way. It should be a little bit down. Oh wait, not the body. My bad. No, front left. Minus 0.3. Yeah, this should be this should be good. Minus 0.3. And after this, we're basically oh, and also if you have a car, you also need a ground to actually drive the car on. So what we're going to do is add a plane to it. This plane is basically what it will act as ground. So I'll just rename it to ground. And after so for the ground, it is too small. You won't be able to move that much. So I'm going to increase its scale to approximately 30. Yeah, 30 by 30 is good. But now if I deselect it, the only way of identifying your car is with the shadow. uh, if I get the correct perspective, this car is basically invisible. So what we're going to do is add a material. We will later replace it with a texture or a proper 3D model, but for now we will add a material that will allow us to basically differentiate between the car, the ground, the wheels, etc. So I'll just create a new folder, because the materials, it's a different kind of asset that we're storing. And if we stored everything together in the same folder, it will get cluttered and disorganized very fast. So materials. And in the materials folder, what I'm going to do is I'll create a material. This is the car body material. And now a lot of sliders and boxes have appeared on the right, so I'll talk about them. This is the rendering mode. Just keep it opaque so that you can see it, so that it is visible. And albedo is the value that we will be changing. So first I just go to the car body and apply this car body material to it. No, we remove. No, yeah, we go to the body and add here. So we got the car body material. Now if I edit this, you will see the change directly. A car, according to me, cars look good in any color. They're like Skittles. Any color is good. But I do have a soft spot for this shade of blue. So this is what I will be using. And the metallic value is basically how dark and light it gets over like angles and different light values. So I'll increase the metallic to around 0.8, and smoothness is basically how reflective and how how smooth the surface is. So I'll because come on, it's a fresh car, it should have very smooth surface. 0.92. The normal map, height map, occlusion, and detail mask, they are basically images that define various values. A normal map is basically the surface imperfections, like small bumps that would take a ridiculous amount of rendering power to do if it's in the 3D model itself. A normal map does it directly through the texture. And a height map, it modifies the 3D model itself according to something that's similar to a normal map. Occlusion and detail mask, it is these are for the lighting and shading. Then you have emission, that it's for light emitting bodies, like the sun, like other stuff. And tiling is where, like, if you have a texture, if you have a single texture and it is like too bland, because like a single texture over a very large object, it will get blurry. Even just for reference, I'm using a 30 by 30 now. So if I use a 2048 by 2048 texture file for this, it will get super blurry at scales of 15 by 15. That is not good. So what we do is we tile this value. We just tile the texture over and over again so that it looks more high res without using that many resources, because even a 2048 by 2048 texture is very big, and it requires a lot of computing power. And then tiling and offset, offset is a part of tiling only. And then you have the secondary maps, a detail map, normal map. It is there for a detail albedo, where you have to add small details like burn marks or scratches. That detail albedo you can handle. And tiling it all, it will also work with this. And specular highlights, it is, if I remove it and I look at it with this angle, look at the top face, and then I enable the specular map. Right now there is not much difference, but it does make a difference when you have like a lot of light in the scene. Now we need a material for the wheels. I call it wheel material. we apply this to all the wheel visuals like this. Now what I did right here was I selected these four by holding down control, and then under the material I dragged this, so whenever I dragged, all this material carried over to all four of these objects. Okay. Now editing the material, eh, it's a wheel now, so it will be super dark, not metallic at all, but I'll give it a 0.3. And smoothness, no. Specular highlights are there but not reflections, and that's it, we are done. And final one which we need for now is a ground material. I'll I'll select the ground, scroll down, and then apply the ground material like this. What this will do is, and now it's the ground, so either we can do it something like a road or like grass. I like roads, so I will do roads. So for now the road will look terrible, but we will have to make do for now. I will create a small texture which will be tiled, which will and that will give us a sense of scale for how fast we're actually moving. I'll do that the moment it's done. The moment we're done with the majority of the coding part. So smoothness very little. Usually all these albedo, metallic, smoothness, normal maps, you do those with images instead of hard values, because each patch will have like a different characteristic according to you. Okay, so the ground is done. We basically have everything separated and that we can see everything separately. Now in the scene we have a few more objects. We have a few more things. First is the main camera. The camera is what the game will display when the game's actually running okay. And directional light is basically a light source. You can use this, or you can use a sphere light source to basically simulate a sun. You can do all that. So I want the main camera to move with the car. So what we can do is just drag it to the car, and now we have everything laid out, but the camera's position is a bit wonky because it will stay fixed with this much relative. So just do it 0 0 0, so that okay, now we're just seeing wheels. That is also not good, so it should be a little bit behind. And yeah, I'll put it like behind the I think 5 units, no, not 5, 8 units, no, 7 units, yeah, 7.5 units. Okay, and no need for left or right adjustment. Maybe camera shake later, I don't know. And the car, it's like sitting too low, even like for simulation games. So we'll put it approximately twice the height, and maybe 10 degrees angle of attack, so that you have a looking down ahead at a kind of a viewpoint. This rotation, this here is in degrees. Okay. Oh, grass would be better, but the thing is, like, we don't exactly have textures right now. We're going to have to add them later. Okay, so so that's why I'm using for now this thing. And making a grass texture is far more difficult if you are doing it from scratch. So we need to find good textures online. Now now we get to the scripting portion, which will determine how the car will move. Okay, I'll create a I'll create a folder and I call it scripts. This is where all the scripts will be stored. So I create the I create a C# script, and this one will simulate the car sim.cs. And oh right, okay. One thing you need to know, like after you've installed Visual Studio Community, is that you are going to have to change the external script editor, going to preference, external tools, external script editor, and selecting Visual Studio Community, and generate CS project files for embedded packages, local packages, and built-in packages. These ones are the ones that you need to basically take care of, and you select regenerate project files every time you change these settings so that it's updated. Okay, and now for the scripting portion, we go to Visual Studio Community. How I did that, just wait a bit, because Visual Studio is a fairly heavy application, and yeah, Visual Studio is open now. How I opened Visual Studio is you basically just right click on the project panel, and you go to open C# project. If an external tool is not specified, it will open the project folder. It will open the project folder, and if you have Visual Studio Code installed, the Visual Studio VS Code set, then it will open a VS Code, but usually it's not exactly recommended for you to use VS Code for Unity development, because a lot of the syntax highlighting and the not the syntax highlighting per se, but the class names and IntelliSense and IntelliCode, it doesn't work with VS Code and Unity. Like, they don't work properly together. But VS Community works like a dream. Okay, so here we are at the Solution Explorer. You go to assembly-C# assets scripts. Here we have the carsim.cs. One thing to note, always use tab spaces when indenting, because it is easier to navigate. I'm pressing singular arrow keys right now. Okay, so after this we putting tabs, and just modifying this to basically be more comfortable with yourself. We will have 4 wheels, right? So we need to simulate the wheels as well. So I think I should be creating another C# script here. Okay. C# mono behavior. It's a mono behavior script. All these simulations, all the scripts that are like directly used by Unity. Okay, we'll have wheelsim.cs. Okay, now that this is done, oh, come on, VS Code, just find yourself, mate. Okay, so a wheel will have quite a few attributes that it will be using. Okay, so the first attribute that we need is radius. Oh, and before that, one thing, like you see 2 functions whenever you create a mono behavior script. a start and update. What start does is basically whenever the object is created, this the start function is executed once and never again. Update function is called every time the frame updates. That is, like if you are playing the game at 150 frames per second, the update function will be executed 150 times per second. There is another one which is similar. It's called fixed update. And this is called every time a physics time step is passed. It's you can set those in project settings, but usually between two frames you will have four physics time steps. So so if you are playing the game at 150 frames per second, the game this fixed update will be executed 600 times every second. That is a lot of execution, so we should be careful and keep it uh, as concise and fast executing as possible, so that you don't affect your game performance as much. For now, we won't be making use of fixed update, we'll be only using the update function. So back to the wheel simulation, we will have the wheel radius, how fast it's rotating, that's the revolutions per minute, RPM, and grip coefficient, that's like how much grip it has, how much grip it has at the moment, and a public animation curve, grip slip curve. So what's an animation curve is that it's basically a continuous curve that will have a value set for each and every each and every like input value that you give it as a continuous function. Okay, it is very useful in both animating animating characters, which is basically the main reason for using animation curve, and another it is when you need a smooth continuous feedback. Okay, and that's why I'm using animation curve here. And then we will be making use of all the wheel will be accelerating and steering as well, so we will have all the things that will be needed. Oh wait, no cap. Just let me know through the chat if the text size is too small. I will make that so that it's more comfortable. For now, I think this font size might be a little bit uncomfortable if you are not watching on a computer. And yeah, acceleration force, like how much force it's giving. Then we have public bool is powered. Okay, so bool is a boolean, or a binary value, like true, false, yes, no, 1, 0, that's it. So is powered, that it's basically a value that you associate with the uh, uh, how the wheel is, like is the wheel powering the car, is the wheel powered, is it pushing the car. So it is, if it is powered, yeah, it's true, and if it is not, it's false. So after this we head to the steering, like float, steer angle, Bull steers car again, just so that we know that this specific wheel is actually steering the car. After that, a few miscellaneous stuff. That's like how much speed the individual wheel is carrying. Is grounded. Is the wheel on the ground? Because if the wheel is like not on the ground and it's like you're putting like acceleration force on it, and it doesn't make sense because there's nothing for the wheel to dig in. So it's grounded. And public float hit distance. And the rigid body, it's basically a reference. It's basically referring to the parent object's rigid body. Okay. Then in the start function, when we are like initializing everything, all that we'll initialize is the parent rigid body, because the rest we will be able to initialize directly from the game engine itself. Okay. And after this, parent rigid body is equal to get component in parent. This angled bracket, it will make sure like what type of component you need. You need rigid body, and yeah, this is initialized. Now we'll do the now for update function, what we will be doing, we'll be checking if the wheel is on the ground. Okay. And we'll be applying the acceleration force that will be given, and we'll be applying the steering force that will be given. uh, for that we are going to need so for putting all of that in just the update function, it is cumbersome, so we're going to put it in the we're going to make separate functions for that. So the first function I'm doing is checking if the object is grounded. For checking the grounded, what we will be doing is I'll first make the code and then explain. That's it. Okay, so what we're doing in this function is ray casting. So what it does is you take a point, you shoot a ray in one direction and see if it hits anywhere. If it does, uh, yeah, you get the information of like which direction it is. If I just come here and do a hit dot, so that it will tell me what all is here. What is it telling me? Like transform like exactly where the hit is landing. Okay. the the texture coordinates, the what rigid body is it colliding with. Okay. The point, like which point in the global space is it doing. and we have the distance, like how far it is. All this is like all this is super neat methods, super neat functions. Okay. After knowing the how it is, like where we are, uh, if we are on the ground, we should work on the acceleration. I'll call this function the accelerate. Now, if the wheel is not power, oh wait, I'll first make the function because the time, like I wouldn't want to take too much time now. So if not is powered, return. If not is grounded. Okay, what we did with just this much of code is that we calculated how much the wheel is slipping. Okay. After we have found the slip, we can find how much grip the wheel will have. So the coefficient is not evaluate slip. acceleration force we need for okay, right, acceleration force we don't need to. Okay, okay, then we found the grip, we already have the acceleration force. Then what we are going to do is we find the applied force. Vector 3 applied force is equal to new vector 3 0 0 acceleration force. It's either pushing you forward or backwards, so the only axis we need is z axis. So acceleration force and grip coefficient. This we got how much force we need to apply. Then we apply the parent. Okay, we apply the force to the parent so that it like gives it the whole thing a push. So parent rigid body at force at position, applied force at transform dot local. Now we are done with the acceleration part. After this, we are supposed to do the steering car. Apply steering. Then we have this one that is supposed to be for the steering. So if not, steers car return. Alright, what this return is doing, like if it's like not powered, it's going to skip everything that's there next to it. So yeah, and then transform dot look rotate. Okay. And the Eulers. For this wheel, let's take a look at the front left in a top-down view. So if we are trying to rotate, okay, so a positive rotation is to the right and negative is to the left. Okay, that is good knowledge. So, and it we need to do for the y-axis. So get component parent oh wait, no, it's already it will already be applied to the container, so we don't need to do the parent stuff again. So transform dot rotate and our application vector 3 vector 3 rotation steer equal to new vector 3 0 comma steer angle 0. So from that, steer and it should be space dot self. Okay. Now that we are done with this, I think we are basically done with how the steering is supposed to go. This the wheel level steering. If we when we were doing the actual proper steering stuff, we will be making use of we'll be making use of the car simulation for helping out with this. And in the update function, we will update the speed to be parent rigid bodies speed dot magnitude. So speed is basically velocity is magnitude. Velocity is a vector, and speed is like the speed is just a number. So you can't exactly like use them interchangeably. So speed is done. Then we check if the wheel is on the ground. Apply acceleration, and we apply not twice. And then we apply the steering, and basically our wheel simulation is done. The next is the car simulation. Okay. And wait, I'll just apply this to my to one of my wheels so that you can see how it is supposed to look. Rather, let's just do all the wheels. Wait. Okay. Now all four of them have have this stuff. The grip slip curve. This will be the curve that defines how much the car will slip and all. And I mean, all of these values together like this, it is quite difficult to follow. So what we're going to do is make use of headers for the inspector. This is called the inspector tab. So we'll make use of headers in the inspector tab there, so that it looks a little bit more presentable and more readable for us. Okay. So to use the header, I already did the spacing so that I know which one is which. So we're going to go for header. Yeah, that's one thing about VS Code. It won't Visual Studio Code will not give you this kind of intelligence that is giving me, like header. It's like telling me, okay, you might be using this. So that's why VS Code is very much preferred when you are doing all this. Steering, and last is it's this miscellaneous stuff. So miscellaneous. I save it, let Unity load it, and look, now there's headers separating all these boxes. It is good. It allows me, I'll just edit all four at the same time, so that so point 8 is the not 8, 0.4, because the 0.8 scale here is the diameter and radius is half of that. Okay. Then the grip coefficient is calculated on the fly. We just need to see it from time to time. The grip slip curve. Okay. So when you are editing these curves, you can use these presets which are there. Okay. But what we're doing is we have a completely customized set of values that we're using. So we'll just change this. The initial grip will be high. Wait, a little bit lower. Okay, this works. No, it doesn't. Zoom, 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 zoom. Oh, okay. Then wait. Okay. Then what we'll do is add a key. This will be a value which will be seen here, seen in this. This is a tangent, like which direction and how do you want it to go. I add another key. The grip slips. Oh, right. Yeah, one thing about animation curve is that you can't exactly like edit it completely, fully freely. And that's how we're going to work. I save this, and this is our grip slip curve, how it will go. Front left steers the car. And that's the thing, like this is like the perspective view. This is a perspective rendering where like the closer objects they appear bigger and they move a lot more than the farther ones. And then you shift to isotropic view. There is no shift. It's easier when you it's easier to see this, see it, see the object geometry when you're editing it. Yeah. And after all this, like, okay, oh right, no, rear left is not steering. Okay. Yeah, and the rear wheels, they are powered. The speed is calculated on the fly. Steering angle and acceleration force is it is given by the car simulation script later. So we're basically done with the wheel sim. Then we go to the car sim and we edit that. Wait, mixed, it's saying converted to tabs. Thank you very much. Then we have this one. So what we will be doing for the cars is that uh, we'll have four wheels. Okay, and those four wheels we would want to be uh, referring them as arrays also, so that it is we can access them easily. So I'll just create another class. You can have multiple classes in a single class C# script, but only one can be the mono behavior that will be used by Unity. Okay, I'll call this wheel set. Okay, this is my own thing. Public front left, could not be found. This is interesting. And if we go to public, could not be found. Okay, this is strange, very strange. Is it with the spelling? I think. Oh, okay. Okay, I see what happened. Okay, so basically, VS Code, when it was initializing this script, it, it shifted the assets. Right now, all I'm doing is making the code indentation correct again. Don't worry, it's not that long. So tada. Okay, and now the wheel sim, there's no red underline, so we're back to working perfectly. So public wheel sim front right. Okay, and I need a constructor here. This function is called a constructor, and it is just like start function, but for other classes and stuff. So what we'll be doing here is initializing the wheel set. And okay, yeah, count is 4, then okay, wait, we can't basically. Okay, never mind. uh, we'll just initialize this in the start function itself. Now what this get set thing is doing, it will allow us to access this directly like an array. Type expected. Okay, okay, never mind. So here get switch of I. Okay, we're almost running low on time, so I'll try and finish at least the core mechanics as fast as possible. Okay. Okay, then we have the setting. Okay, now that we're done with this portion, this part of the code, it will allow us to access these four elements like an array, wherein like you just address them like ARR0, ARR1, all that stuff. After we're done with this, I'll just hide this because it gets long. Yeah. Oh, and also I'll remove this comment. It's just using a space without any utility. Now with this one, we're going to now a car sim will be way more complicated. So the first thing we will have is insert wheels. Okay, this is the power. Then we need the transmission. And the steering what we will need, the wheelbase and track width. Do we need track width? Yep, we need the track width. After this, yeah, the inputs. Okay, these are all the variables that we will be needing. I know putting all of them together just like this is not exactly that intuitive, but uh, but we will have to work it like this. Now after all this, we will be initializing all the variables, or as many as we need. So the moment you start, the engine is basically stopped, and we count how many wheels are powered, because that number will be used many times when calculating the and then when calculating how much force we will be putting into the wheel sim. Okay, so the powered wheels is 0 to start, and also we will be okay, we are going to have the wheels new wheel set dot count equal to 4, because 4 wheels are already there. Wait, powered wheels later, first we need the wheels. Wait, no need for this. Okay. Wait, never mind. I am okay. I is equal to transform dot get. Yeah, I'm not sure. I'm not sure how the get child will work. Okay, so so for now I'll just comment this out, and we will check what it shows for the transform. Okay, so what we will do is yeah, transform dot child count. Just a second, I will need to pause the stream for a few minutes. Okay, I have returned, and now to continue with all the checking what it will show. So debug.log transform dot get child index I dot think then name save it, wait for the script to load in, and wait, am I audible right now? Just allow me to check. Yes, I am. Okay. Yeah, the script is loaded. We add this component to the car first, and we play. Let's see what it is showing. Okay, it showed body, front left wheel, front right. So it will be 0, 1, 2, 3, 4. 1, 2, 3, 4. Okay. That component wheel sim. Debug.log I. We're done with this. We'll reload the script. Just do that and then do it again. Let's see what it is saying. Null for 0, 1 for this, 2, 3, 4. Okay, it's working fine. Okay. Okay, we can use this directly. So get child I plus 1 dot get component we don't need for this log right now, and continuing with where we still are. Just a second, I need to keep the chat open as well in case anybody asks anything. Our wheels have been initialized, then we do the powered wheels count. Powered wheels equal to 0, then for I equal to 0, I is less than if wheels I dot is powered. Sorry. Yeah. So if wheel is powered, we will increase the value of powered wheels by 1. And also we start with the current gear as 1. I will show you in a bit like why we're doing this part. So after this much, we will, for update, we will be syncing the RPM. We will be responding to all the inputs that will be made. So first we should, I think, configure our input manager so that it will read the inputs the way we want it to. So we go to edit, project settings, and here input manager, going to axis. Horizontal one is the one that we use for steering. steering. Then vertical is the one that we use acceleration. Also, I have to keep it a little bit customized for myself, otherwise I won't be able to. This is the handbrake. Acceleration, steering, and gear up and down. S, X. This is the gear down. The rest are not exactly needed. But still I will keep them, because you never know that something else might break. We save it and get back to the coding. So the first thing we'll do is sync the RPM of the engine with the wheels. How this will work, I will show. I'll first make it a different function first. So void RPM, right, sync RPM. Yes, code options. Keep tabs. Thank you. Thank you very much. Now just convert it back to tabs. Thank you. Okay, so syncing the RPM. So, oh, not float. Average RPM. We started with 0, and as the so we progress through the wheels. Wheels dot count plus if wheels I dot is powered. Oh, average RPM, we increase it by RPM. And this average RPM is not for the wheels, this is the average RPM of the engine. So that's why we're using the current gear here, the gear ratio, which will be for the transmission. So once we get the average RPM, we basically set the engine RPM to the average. This is how we will sync the RPM. After this, the acceleration response. So void accel input response. Yes, these function names are long, but that's because I prefer readability and ease of understanding over doing everything in single complicated steps. Okay, just deal with it if you want to. And after this, we have accel input. So the okay, accel input dot get access. We just named it to acceleration. Remember, these name is case sensitive, so if in the input manager, if you kept it small a here and capital A here, it will basically not read anything. That is very important to understand. So we have the acceleration input, the power that is sent to each wheel. That is something that we will need to calculate. So if our acceleration input is less than 0, that means we're braking essentially. Then our engine, then we will calculate it using the wheel power. So sorry, using the brakes. Okay, so per wheel power it will be brake power dot evaluate acceleration input. So here I am doing directly the input because it doesn't really depend on the RPM that much. It just depends on like how hard you press the brakes. Okay. Then if oh, okay. Right, brakes are applied to every single wheel, right? So we will apply it here in this if block only because the other other ones will have different applications. So if no, not if, for I equal to 0, I is less than wheels dot count, we increment I, and then wheels I dot acceleration force equal to per wheel power, and that's it. Then otherwise, if our input is greater than 0, that means we are accelerating, that means we want to go ahead, then it becomes a little bit more complicated. Okay. So here our per wheel power, it will be engine power dot evaluate. We're using the dot evaluate because it's an animation curve. You can't exactly do it like an array. Okay. So then we will have evaluate the engine RPM, not power, RPM multiplied by throttle ratio, which is basically how hard you're pressing the accelerator, dot evaluate axle input divided by ratios dot ratios current gear. Yes, it is that long to actually do this and powered wheels. This is how you will calculate the power that will be sent to each wheel. Then we're not exactly coding any differential, limited slip differential, etc. So it's a fairly simple driving model, simple compared to other games which you conventionally play. For example, Forza or Grid or Need for Speed, etc. Okay, now after all this, okay, right, we're done with this. Then we add the I equal to 0, I is less than wheels dot count I plus plus. Here, if the if wheels I dot is powered, acceleration force per wheel power. Okay, and then final else, that is you are not going ahead, you don't want to go ahead and you don't want to go back. Then what we will be doing here is, oh wait, right, car is already stopped. So if the car is already stopped, we don't need to do anything, we just return. Okay, so if get component rigid body dot velocity dot magnitude is equal to 0. Return. Don't do anything, just skip. Okay, and the rest don't have this constraint. Okay, the final one is, it's basically the same as calculating this one, but you're using a different, oh no, no, VS community, what are you doing? Instead of engine power, neutral power that you're using, like, no. And other than that, it's all the same. This is our throttle response. Yes, very complicated. Steering input response. Now this will be the last function I'll code for today. Oh, and also handbrake as well. Okay, this is the these two functions will be the last ones that I code after, and we will work on it next week. Okay, so stay tuned for the next week's stream. Right now, okay, we pull the okay, right, we're doing the steering. For steering, we have I'm making use of the ideal steering angle formula. Axis steering. If oh, it's not steep. No, not steep. Sorry guys, but my okay. Right, we will need the radius, left angle and right angle. Okay, if the steer input is steer input is less than 0, we'll be turning left, because as you can see from the input manager, yeah, input manager steering, if you left is negative, so so then we will be so then we'll be using the formula for this. It is the left angle is the not a tan. A tan is basically the tan inverse formula. Wheelbase by radius minus track width by 2, and right angle is equal to mathf dot a tan radius plus track width by 2. Okay, and then we put an else. Wait, okay, and then we put an else here because the 0 is already eliminated, so either it will be less than 0 or greater than 0. So greater than 0 is a right turn, so we'll just take this. It is unhappy. Okay. Huh. Oh, right. I missed this. Okay. We just copy this and invert it. So left becomes right and right becomes left. Now we have the angles, and then we just wheels dot front left dot steer angle left angle, wheels dot front right dot steer angle equal to right angle. Now we have the steering input done. Then we need to do the handbrake. Void pull handbrake. Handbrake is basically you just you're basically stopping the rear wheels only. Okay, so wheels dot rear left dot acceleration force. Alright, handbrake doesn't really work if the car is stopped. So if get component, wait, we're making use of the get component rigid body quite a lot. So what we're going to do is have a miscellaneous. No, wait, no need for miscellaneous because it won't be visible. Rigid body RB. This will be the this object's rigid body component. So I'll just initialize it here. RB equal to get component rigid body. So now instead of all this long, we just need RB. And instead of this long, we just need RB. Oh no! Oh no! 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 You misbehaving child. Okay. If RB dot velocity dot magnitude is 0, return. You don't need to do anything. Then otherwise, acceleration force equal to brake power dot evaluate -1, and it's dot rear right acceleration force equal to brake power dot evaluate -1. Where we're done with the handbrake, we'll just implement all of these and we'll be done with it. Okay, and now we just need the update function we need to work with. So in update, what we will do where is update? Right, when you're working with big code, always remember that you should shrink the big functions so that you can find things. Right, sync RPM is already there. Axle input response, we're done. Steer input response. Okay, if input dot get button down gear up. Let's just confirm if the gear up is correct, because okay, it is correct. then our current gear is increased. Here you don't need an else, otherwise the input will get janky. You will be able to use only one button at a time, so that is not a very uh, helpful ability. So now we're done with this. Alright, if you're trying to shift up and you're already at the maximum, you wouldn't be able to. So, and current gear is less than ratios dot length minus 1. Okay. And the same with here. Wait, is the mouse? Okay, okay. So the same with here. Like if you are already at like the minimum, you wouldn't exactly be able to go to a lower gear. So, and then current gear is greater than 0. And the last is the handbrake, which will be the last uh, functionality I'll add without testing yet, and we will see how it works. I'll just pull handbrake. Oh, okay, we're done. Saved. We're done with all this. Oh, right. I mean, having this number for input representation, even if it's just for the developer, it doesn't look right. So what I will do is change the just like how I added a header, I will add a slider here, which will just show. So this will be a range minus 1f, 1f. Same here, minus 1f, 1f. So why minus 1 and 1? It is because inputs raw values are always ranging between minus 1 and 1. That's why. And this the ratios. I'll just do the same for the RPM as well. It just looks good. Range. No, we're going from 0 to say 15,000 floating. Same for the red line. Okay. Now that we're done with this, we come here, and now there's sliders here, which we can use. This is super neat. Okay, now engine power. That's what we're here to do. Okay, we need 200 on the y-axis. Okay, 200. This is like the normal zoom, and if you want to zoom just the y-axis, you can do it with the you can do it by holding shift while scrolling, and if you want to do just the x-axis, you can do it by holding control while scrolling. Okay, now that this is visible, Now we're done with the engine power. The neutral power we need to edit now. I'll just copy and paste the engine power and then edit that. Edit through this. So for the neutral power, what I'm thinking is that we make that ultra short. Just move the power a little bit more down, and we're basically done with this. Then the brakes. So for the brakes, what I will do is take a normal curve and shift it. Okay, so that it is start ends here like this. Oh no, this is okay. Then we add another key like so. Okay. Now we're done with the brake response as well. Oh wait. Mm. Oh, okay, 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 brake power. Okay, so we just take this. Wait, this is fine. This is fine. The Y. Let me extend the Y-axis. It's got pretty decent braking power, and okay. Then the throttle response. Okay, throttle response is just for acceleration, so the X will be greater than 0. So a standard this will do, and add a key here like this. Okay, we're done with throttle response. Then gears, I'll just add 3. Okay, one will be a -1, -1, 0, and a +1. And okay, wheelbase. So front left is 1.3 and rear left is -1.3. So wheelbase is 2.6. Track width is 1.8 that we set. Steering radius now. For steering radius, let's just keep it at 10 and see what happens. And we're saving it around each and every wheel. Right, it was all calculated on the fly. Then let's see. Okay, it is trying something and it's going horribly bad. Go to the top. Okay, it's which one is it freaking out at? Rigid body force assign attempt is not valid. Okay, call stack is at wheel sim 69. Oh, 69. Okay, okay, at 69 we'll just stop it first. So wheel sim 69 is this one. Applied force is acceleration force into grip coefficient. Okay. Okay. So the starting acceleration force, we need to assign it so that it's like so that it's happy. So in start we can do that. So okay. Now what does Unity have to say? Hmm. Now it's at 71. Okay. Okay, it is still not working. Okay, okay, okay. Grip coefficient. Okay. Okay, we'll just comment it out for now and see what the debug log is trying to tell me. Hmm. So the grip coefficient is running nicely, but it is the applied force. So acceleration force is the problem here. Okay. We stop this then, and acceleration force tell. Hmm. Okay, okay. It's actually not really. Acceleration force is assigned here. It is this. Is the wheel grounded here? Hmm. Okay. Now we get it. Okay, what if I give input? Oh, okay. Let's see what happens if we actually give the input. Yeah. Okay, it's actually doing something. If we go here, and there it is. Okay. Hmm. CS 126. Okay. Uh, okay, it's current gears. Hmm. There it is. Oh. Okay. Okay, it's the gear up function that's the problem here. Okay, I'll just keep it 0. It's shifting up on its own. Okay, now that we know. I think it's something to do with the project settings. Just look up the gear up, gear down. Gear up is S. Snap. That is the thing that we needed. Okay. Oh, wait. Instead of get button down, if I got get button. And now we try. No, no. Oh, okay. Right. But the snapping is still needed. Okay. Now we try. Hmm. Hmm. Okay, it's shifting up on its own. Right now we're running out of time, so we'll leave it at that. I will try and find a solution to this as soon as possible. And that concludes for the today's workshop. We will continue this next week. Thank you and have a nice day.